Hello, everyone. Welcome to the January edition of MobiTalk. We are a meetup of mobile app developers, and we conduct monthly events and talks for iOS relating to the topics of iOS and Android development. We are so excited that you guys have joined us today. You can connect to us on WhatsApp using this link, which we'll be sharing in the comments. And you can also follow us on MobiTalk HQ at Twitter. The topic for today is an introduction to concurrency in Swift by Mudit Kapoor. Mudit has been here with us at PayPal for 2 years as a software engineer. Uh, we'll wait for a few more people to join and then we can jump in. Mudit, you can go ahead. I think we can get started.
All right. Hi everyone, this is Mudit. So yeah, Gauri already introduced me. But actually, I only started developing with iOS once I joined PayPal. So I got a lot of push from my manager, so thanks to them. But okay, you're not here for me. You're here for learning concurrency with Swift. So I say that this is an introduction to concurrency, but actually I'm lying, as you can see by these many slides. This is more of a pretty good overview of everything that's available in with the Swift 5.5. And keep in mind that this is like really changing really fast because the things that I learned from, like I watched Swift WWDC and they're really good videos, but they've already become kind of deprecated. So, and those were, I assume, before Xcode 13 got released, and this is with Xcode 13.2. So by the time you actually start working, maybe these will also get deprecated, but that's a good thing. That means we are uh, it's a constantly evolving language, so that's good. Okay, so let's start the presentation. Okay. So the first thing that I'm going to talk about is the problem with completion handlers. So if you've got any experience with Swift and any experience working with, say, network calls or anything that's sort of not happening instantly, you would be giving completion handlers. And uh, I'm going to show you an example of why it's such a bad idea to be using completion handlers like this. And after that, we're going to look at some of the features that Swift it makes available in 5.5. So like async await, sequences, async led task factors, all of these things. And then I'm going to have a small section on how to start using async await and all these related features in your already existing projects. How do you migrate to using async await? Okay, let's see. And this is like not just completion handler, it's also delegates which have this problem. So let's start with an example. Okay. Uh, the example is like this. I want to download an image from the web and I have some ID. I create a URL using that ID. Okay, that's a synchronous operation, no problem. Then I'll download that data, asynchronous operation. So I'll require a completion handler. Then I'll convert that image to data, no problem. That's a synchronous operation. And then I'll be preparing a thumbnail using that. Okay, so let's look at the code. This is my function, and this is the completion handler it's taking. All right, this is the URL. So that's just one line. All right. Now we're creating this task and we are resuming the task. That's great. And we are passing this completion handler with data, response, error, all of that stuff. Okay, so we check the error, and if there is an error, we return, we call back the handler. Okay, if there's some status code, we call back the handler. If I'm not able to get some data, okay, I just return the, if the data doesn't convert into an image, I return. Okay, and if I am able to prepare if I'm not able to prepare the thumbnail, then I return, and otherwise I call the handler with my thumbnail. Okay, now like I'll give you like 4 seconds maybe, and there's some issue with this code which is not really obvious at first glance, and it's something that I've actually noticed in production code. uh, People make this mistake very easily. It's not obvious when you make the mistake that it's actually happening. uh, the issue here is that in these two places, I'm just returning without actually calling the handler. So if something like if the data doesn't convert into an image, or I'm not able to make the thumbnail, whatever place that called this download thumbnail will just be stuck. So if I had showed a loading spinner at that place, and one of these case scenarios happens, that loading spinner will spin forever. There will be nothing to stop it. So usually, if we get the error, we'll stop it and do something, or if we get the image, we'll stop it and show the image. But in these cases, nothing's going to happen. That spinner is just going to stay there. So this is the issue, and there's no way for the Swift compiler to actually be able to statically tell you that you're making a mistake here. Look, okay, so let's the compiler is there's no compiler support to ensure that the result is always there. And as you've seen, this is just like four things that happen. Like it should be like maybe 5-6 lines, but we have these, I don't know, like 15-20 lines of code, and this is with indentation level 2. Otherwise, you can imagine, you must have heard of pyramid of doom, right? The code just starts going sideways. It's not easy to read, and it's not as easy to get what the code actually wants to do. So let's see how the async await can help us here. Okay. So first of all, what is an async method or a function? So synchronous methods, they return the value, they throw an error, or they're not returning anything. They're just performing some side effect. So this is what a synchronous method can do. What an asynchronous method, it's everything that the synchronous method can do, but it can also suspend partway. So if it's waiting for something, it will just stop, and someone else, the Swift executor will assign some other thread to do some other code on that thread. Uh, so we're not wasting any time. Okay, so yeah, this is the same function, but instead of having a completion handler, this is going to be an async function, which is going to return the UI image. And if there's an error, then we'll just throw that error. Okay. Yeah. So like we had this URL session.shared.data task with URL and with this huge completion handler. With Swift.5.5, we have new methods that are asynchronous, and they just return the data asynchronously. So when we are accessing those methods, then we'll need to await those. And since this method also throws this URL session.shared.data, this also throws, we'll also need to try it. Okay, so if we do get an error here, our function will just exit out with that error. So at this point, the code will actually suspend and wait for the data to come. And during that time, the executor will be running some other code in this thread. So yeah, so when that data actually does come, then we can start working on it as if as if nothing had happened. There was no delay here. We can just start working on it like that. So we check that status code and we throw if it's a bad status code. Okay, and now we can just get the image, and we can get the thumbnail from the image. So you're noticing this is also an await here, because you can also, not just functions, you can also make computed variables async. So this thumbnail variable is an extension to your UI image, which is an async computed property. And you can just await here, call the self dot by preparing thumbnail of size, which is also provided by the Swift Foundation. This is another async method that's available, and you can await it and you can just return that value. So see, this code is so much simpler to read, 6-7 lines of code. Every point is compiler checked, so that we are never not returning a value. And this is the reason that the async await paradigm was even introduced. So if you look in the Swift Evolution's GitHub page, where they are doing the proposal for this, they show an example like this, and lots of more examples, like with delegates, with results, and all of this stuff. So you can go and check that out. Okay, so let's look at it in a more clearer light. The async keyword enables the function to suspend. So if it's your keyword, if your function is not marked as async, you will not be able to suspend on it. The await keyword marks a possible suspension point, and only at these possible suspension points can your code ever suspend. So it will never suspend when you're running synchronous code. It can only suspend when you have marked it as await. And every possible place where you can suspend, you have to mark it as await. Yeah, synchronous lines of code are never suspended. While suspended, yeah, the runtime can yield the thread to some other asynchronous code. So we are maximizing our efficiency. And once the data is actually available, we'll resume after that. Okay, so that was the async await. That's the kind of introduction, the very core basics on which everything else is uh, built on. So these are all the helper things that I'm going to start talking about, and some things that are basic, more complex, but we'll get to that later. So if you have any questions right now, I would suggest that you can just tell me at this point whenever I get to a new section, so we can pause at that time.
Sure, Mudit. If anyone asks for a question, I'll read it out to you.
Yeah, thank you, Gauri. Okay, so let's go ahead then. Let's look at async sequence. So earlier I just showed you a way to get one value awaited, but what if you have a sequence of values that come in, and you want to loop through them? So what an async sequence does, you define your async sequence, and you'll be able to get values one at a time, uh, without actually having to get all the values and then putting that in an array or something. You can get those values one at a time, based on the requirement. And like sequence, we had the for in loop for sequences. We have the for await in loop for async sequence. And like sequence, the async sequence contains like all these helpful methods like map, filter, reduce. All of these things are also available in async sequence. So let's look at an async sequence. So if you guys have ever created your own custom sequence, it's very similar to that. So we have a countdown sequence. It's asynchronous, and we just need to conform to the protocol async sequence. And for ease of use, we'll also conform to the protocol async iterator protocol. This makes it so that you don't have to create your own custom iterator. So all of this is extra fluff, which I assume Apple is going to remove in a couple of releases, because when you're creating a sequence, you don't have to do any of this. But this is just fluff that says, yeah, the iterator is the same class, and the element that we are going to be returning is going to be an int. But you don't need to focus on this too much. Yeah, these two are the things that we need to focus on. So this is our state, the count variable, and this is the next method that will be called to get the next method in your sequence, the next element in your sequence. So, and it's async, and we're doing something. So in this case, we're just checking if it's 0, and then we're returning nil to mark that the sequence has ended, or otherwise we are decrementing and returning the value. And we can use it in this way. So we create the async sequence, and we can for await the variable in the async sequence, and we can use it however we want. So instead of doing this synchronous code here, you could be, suppose you were making a network call, whatever you wanted, you could do that here, and then you can return the next value. Let's also look at the other variation where we mark this next method as throwing. So in this case, I'm not throwing anything, but just by marking this, I can say that, yeah, uh, this method can throw. So to use it, I'll have to do for try and await or try await. Okay, as simple as that. Whenever something is actually throwing, you just put try before that. That's great. All right. So there was async sequence, and you saw this is not like a very convenient way to declare something, and you're not also not buffering the elements. So you're going to have to wait every time. Okay, so once I've processed my variable, and when I call the next variable, at that time it's going to start getting the next element, right? So what if you just wanted to buffer those elements? What if you're getting those elements not from like calling some function or something, but you're getting those elements from a delegate or something? So for that, we have an async stream. So produced elements get stored in a buffer, and it's a much more convenient way to write this without having to declare those iterators and all that. And callbacks and delegate based APIs are very easy to convert it into an async stream, which is just async stream conforms to async sequence. And you can also give a buffer length if you want, but it's max int by default. So let's take a look at this example. We have a flight tracker class. What it does is when you start tracking, then it will call this callback flight took off to say that this flight took off. Okay, and we'll have some details in the flight, like from where and where is it going, all that stuff. Okay, so let's create an async stream with this flight. We get an async stream, and then we can start with this continuation. This continuation enables us to, I'll show you how we can use this continuation. But basically, you provide the type of the element, which is a flight over here, and you can start with this. Okay, let's create our tracker with the, and this is our callback that we are providing to the tracker. Okay, if we do get a flight, let's yield that element. So basically, this will get stored in the buffer, and whoever's awaiting can get this, or they'll be waiting for this to appear. And if we don't get a flight, suppose there are no more flights taking off for this example, then we call continuation.finish, and this will finish the loop. Whoever's waiting on that loop will be told that, yeah, this sequence is over. There's nothing to wait for. Okay. Sure, we created this continuation. Now let's start tracking. Let's just tell the tracker to use this callback whenever it can. And one more thing, let's make sure that when this continuation is terminated by, suppose, canceling or something happens, then we make sure we stop tracking this, right? So we don't want this, whatever task that this start tracking kicks off, we don't want it to keep going forever. We want to make sure that it does stop. Okay, so how do we use it? Well, actually, you know what? I'm not just interested in flights in general. I'm interested in flights to Delhi. So with our flights, we created this flights stream, right? So with our flight stream, we can just filter it, and we can say that only give me the flights whose destination is Delhi. And the thing about this is it's not actually going to compute anything right now. It's not awaiting, it's not doing anything. But when you do actually await flights in flight to Delhi, at that point, it will only give you those flights that are going to Delhi based on this filter. And we can like print which location it's coming from. All right. There's actually one thing that you'll notice here. This underscore is here because we actually do get an element, which is the termination enum. And if it's cancelled, you'll know the stream is cancelled, and if it's finished, you'll know the stream is finished. So, but yeah, we had no use for it, so I didn't include that there. You'll also notice this one more thing, sendable, and we'll get to this in a bit. Before that, let's also take another example, and here we have a callback for the async stream. And in this case, I just made it throwing. So along with the element that it's returning, let's also tell it what type of error we are giving. So I just told it's a generic error. Now here we just give it the callback here we just give it a closure, and it will keep evaluating that closure until it gets a nil. So with the first line, we can put the thread to sleep for 10. This is in nanoseconds, so this is like 0.1 seconds or 0.01 seconds. Yeah, and then some. This is the next two lines are just to get a random flight or nil. So this closure will just keep getting evaluated until it returns a nil, and at that point our async sequence is over, or our async stream is over. So you can use it the same way. Just put a try before the flights, and you can use it exactly the same way. But be careful that you're actually are ending the, like, if you do kick off a task, make sure that you are actually ending it, because in 13.2 at least, the tasks is, there's no easy way to cancel the task that you do start. And this example that I've shown you over here, this doesn't seem to be working. uh, there are some threads about this since August 2021 that this thing doesn't seem to be working, but anyway, besides the point. But yeah, just make sure that you're actually closing the tasks that you do start. Okay, so let's look at sendable and at sendable closures. I was actually going to put this slide much later, but because of Xcode 13, I have to put this at sendable over here, which you don't need to do in earlier versions. So I'm showing you at this point. So basically, sendable is a type that is safe to use concurrently. So what do you mean by that? Uh, well, if we have some sort of integer, and I just copy that integer, send it elsewhere, and modify it over there, that's fine. That the over there, it's got a copy of the integer, right? So it doesn't matter if you change things over there. I still have my own variable over here, which is still, it's fine. There's no issue. But if you send something like a class and then you start modifying in two different places, you're going to end up with problems, because you'll end up with data corruption or data races, all that kind of stuff. So what Swift says that you can only send sendable stuff across a closure, and you can all across different tasks and threads, basically. So you'll never run into this sort of concurrency, the concurrency issues. So yeah, the sendable types are safe to use for concurrency. By default, value types and structs that contain only value types and actors, will get to actors by the end of the session, implicitly conform to sendable. And your classes can be sendable, but you have to be very careful about them. You either implement your own synchronization, or you only contain immutable variables. So in that case, your classes can be sendable, but it's just much easier to use the structures and the actors that we'll be introducing later on. Structures you already know, but actors we'll be introducing later on. And you can even check if your custom type is sendable by conforming to the sendable protocol. So I'll give you an example here. So we have a class baker, and we have a struct bakery, which I'm trying to conform to sendable, but it won't work because baker is not a sendable type. So it will give you an error like this whenever you try to do it. And if you have some sort of generic, and you want to make sure that it is sendable when it can be sendable, so you can put a conditional extension over there. So pair will be sendable when you and we are both sendable. So that way you can make sure things are sendable. Okay, and the sendable closure, basically it just ensures that you can only capture these sendable types, and you're not mutating anything that shouldn't be mutated. So I'll give you an example for when we do something wrong here, and you'll be able to see how Swift tells you. Okay, so this was the async sequences. There's also async let, which is another feature introduced, and it makes it really simple to write asynchronous code where you don't really need the result right now. You'll get the result later. You don't want to await on it right now. If you want to kick off like 2-3 different tasks and you want to use them at the same time, and await at the same time, then you can do that. So yeah, it makes it really easy to write the simple parallel code or simple concurrent code. And uh, it's basically creating a task with some special things that the Swift compiler does. But at the end of it, it's a task, and we'll get to the task in a bit. So this is an example for using async lets. So I have this function that gets a ticket cost, makes a network request or something from the given cinema for some movie, I guess. Uh, So what you do is, instead of awaiting over here, like we've done previously, instead of awaiting, we just give async let like this, and we can get the cost. And we write async let cost to, and we can get the cost. So we don't actually have the value of the cost here, but in the next line, like we can do some more computations here, we can do whatever we want in the middle. But at this point, when we do actually need the values, we can await, and you can do whatever you can just await cost one, or you can await and you can pass cost one, cost two to some function, whatever you want to do. But you only need to await when you actually need the values, so it will return the minimum cost like this. Okay, so let's go on to tasks. So, if you worked with concurrency before, like if you aside from Swift, like if you worked in C or something like that, the lowest level of concurrency comes from threads. But the issue with threads is they're not very user friendly. Like you have to do things like locks and synchronization, mutex, semaphores, all of these kind of things that you have to ensure that you don't end up with issues like deadlocks and data corruption and all this kind of stuff. So what Swift says is, we'll create tasks, and these will be your basic units of work. Okay, you're not going to access threads directly. You'll create a task, and we'll handle the tasks on the threads. Okay, so you don't touch the threads. So yeah, that's what it is. Task is the basic unit of work that it will be run asynchronously. Uh, just like a single thread is not concurrent, a single task is also not concurrent. When you have two tasks running at the same time, then yeah, then you can say I have concurrency in my code. But if you just have one task running, that's just one thread. Okay, so you don't have concurrency. And all of the async codes will run as part of some tasks, and a task will be running one function at a time. And like I said, a single task will have no concurrency. You create tasks explicitly. So in all those examples that I gave, those functions are not creating a new task. They are running on some sort of task, but they're not creating a new task, except for async let, which I said was a syntactic sugar for creating a task. But you have to create tasks explicitly, and you can create as many tasks as you need. So this is the task lifecycle, and this is very similar to threads. So if your task is running, it can go into the suspended state where it's waiting for something. So if it's waiting, then it's waiting for some sort of external event to occur. Like when you're downloading something, you are waiting for the download to finish, and then you can proceed. Schedulable just means that, yeah, I'm ready, and the Swift runtime, please pick me up when you can, and move me to running. And once when you're running, you can either suspend on some sort of await, or you can just complete. And once you're completed, that's the end of this life cycle. You can actually one more thing, you can actually immediately go from waiting to schedulable if there's nothing to wait on. If, like, for example, you just need to switch actor context, which we'll get to. But in some cases, you just this movement is like instantaneous. There's no waiting here. Okay, tasks can be grouped into two types. I'm going to call it two types, but some places call it three types. But there's basically structured tasks and unstructured tasks. So structured tasks have some structure to them. They have a parent-child hierarchy, whereas these unstructured tasks, they you just create them, and there's no explicit there's no hierarchy that Swift automatically creates for you. So everything in the unstructured tasks you have to handle yourself. So in the structured task, the Swift will automatically, if you cancel the parent task, then automatically the child task will get cancelled, and all of the errors and issues, whatever can occur, you will get those at compile time. But with unstructured tasks, you have the complete control, but you're also responsible for making sure that they're correct, that you don't leave tasks running forever, and all that sort of stuff. You don't create infinite tasks, stuff like that. Uh, yeah, examples are like async let and task groups, and the other two examples, task.init, task.detach. We'll get to that. Yeah. So in structured tasks, one of the guarantees is that the parent task is only finished, and it will only return its values when all its children are finished. So even if you don't explicitly wait for any child tasks that you create, the parent tasks will not finish until the child tasks are finished. And the child tasks automatically inherit attributes like this, like priority. Task local values means metadata basically, uh, and yeah, this sort of attributes, the even actor context and all, the child task can inherit from their parent. And yeah, like you have a tree like hierarchy with structured tasks. So you have a parent, then you have its children, and that children will have children. So if you cancel the topmost parent, then that cancellation propagates to all of the children. So let's talk about task cancellation. uh, Tasks, you can either like explicitly cancel it. You can just, if you have a handle to the task, you can just say task.cancel. Or if you're not, if there happens to be some error that occurs in your task and you're not handling it, you're not catching that error, then that task will just it's like abnormal control flow, so the task will just get cancelled automatically by Swift. So when that happens, like I said, all the child tasks will also be given the cancellation. They're basically marked as cancellation. But the thing is, even though the tasks are marked as cancelled, the tasks do not stop running. Uh, it will still run to completion, or you can check to make sure that you don't do any extra work when you're cancelled. But it's a cooperative cancellation. You don't immediately stop the task, because if you do something like that, so suppose you're copying from one file to another, and you have some of the data in memory, and if your task gets cancelled at that point, and you're just told drop everything and leave, then yeah, you'll have a broken file everywhere. You're at the read, where you're copying from, you don't have the file properly, and where you're writing to, you don't have the file. So that's why when you actually cancel the task, it tells it clean up everything and leave as soon as you can. That's what it's basically telling you. Yeah, task will need to explicitly check for cancellation and throw or return a partial result. So this is something that as a Swift programmer, you'll need to make sure that you do check for cancellation whenever it makes sense, because because whoever's using your API or whatever you're designing, they'll also expect that you are canceling and leaving as soon as possible. So let's look at this example. So we're getting movie thumbnails and we're getting it in a loop one at a time slowly. And what we're doing here is we'll do try task.check cancellation. And this will throw an error, the cancellation error, if your task is cancelled. So at this point, your function will just leave with the cancellation error, and you won't actually return any value. But you can also do this one other thing. You can put a if condition and break on task.is cancelled. So in this case, if you got any partial results stored in thumbnail, like if you download the thumbnails for a couple of IDs, so those will be available at this point, and then you return it. But you need to make sure that when you do something like this, when you're returning partial results, your whoever's using your methods or functions, they know that yeah, I can get partial results, because they may break if they don't get the partial results. Okay, so let's look at this other example for demonstrating the hierarchy and how task cancellation actually propagates from one place to another. So I have two functions here, which is get movie details, which will just get the cost, get the thumbnail, and then make a description out of it, and then return those two in a tuple. And this other function, which what it'll do is it'll get the image data, get the metadata, and then it will make a thumbnail out of that, of based on the size given in the metadata. Okay, so you kick off these two tasks. Like remember, I said async let was just a way to create child task in a more simple syntactic sugar form. So we've created these two tasks, and while running, when we try to await for this cost task, it throws. So at this point, we should just leave the method with the whatever error there was, and we don't actually need any of these values. So what Swift will do at this point, so yeah, this awaiting here through error. So what Swift will do at this point, it will mark all the other child tasks as cancelled. So we mark this get movie thumbnail, this task, as cancelled. But when we do that, get movie thumbnail itself has two child tasks, right? Async let image data and async let metadata. These two things we also have two child tasks over here. So we mark these two as cancelled as well. Now, depending on the implementation of these two, it can immediately exit or it can take some time and then exit based on whatever cleanup it is doing. But at some point, they will exit. And once that happens, this is also finishes whatever result it's giving. That doesn't matter. We're not going to use it. But the important thing is that it finished. And only at this point will this get movie details method actually return with this error. Okay. This is a good infographic for looking at all the tasks. And yeah, it basically shows how you can launch the task, what kind of lifetime will it be. So async let tasks are scoped to the statement, and so on and so forth. Uh, I found this pretty. It was a pretty good image. It was shared by Swift. I found this in Swift WWDC. So yeah, let's move on because I haven't actually explained some of these things here, so I can't go ahead. But basically, it talks about what all stuff it inherits from where it's launched. So, like async let task inherits basically everything: priority, task, local values, actors, all of this stuff. It inherits. Well, actors are implicitly there, so you don't even need to inherit those. Uh, Detached tasks actually don't inherit anything, and these guys are scoped to, like, this is the group task are scoped to task group, and async let tasks are scoped to whichever statement is we use to create the async let task. And like these two are structured tasks, so the cancellation propagation is already automatic, but these two are unstructured, so you actually have to call the task.cancel to actually cancel them. And yeah, these two are only launchable from these places, async function and with task group. And the unstructured task and detached task you can actually launch even from synchronous code. So yeah, let's look at task groups, which is a much easier way to do things parallelly. Like I've shown you ways to do things one at a time, one after the other. Like I showed you in async sequence, things are happening. Like we make one network request, we wait, then we make the next request, we wait. But that's not really concurrent code. We want things to happen at the same time, so that we can make 5-10 requests at the same time, download everything. So that's we can do that with task groups. So basically, they're a collection of asynchronous child tasks. They don't really depend on each other, but of course, they have a relationship with their parent, but they don't have an interrelationship between themselves. So you can add child tasks to the group, and they start running immediately, and they are running concurrently as well. And they can finish execution in any order. And this is a very important thing to remember because you can make mistakes if you forget this. Uh, and I'll show you an example later. And even if you don't await the child task, the task group will not finish until all the child tasks are finished. So they are not implicitly cancelled when the task group goes out of scope, but they will be awaited. So that's another thing to recall. And the task group can return void, or it can return no value or some value, or it can return an error. Yeah, and they, like I showed you in that infograph, it shows the in that table you can inherit priority, task, local values, all of the stuff from the originating scope. Okay, so let's look at this example. We have this get ticket cost function which just takes an ID and it will return the cost of the ticket, and it's not throwing, so we'll get to that example later. And this is a different method that it wants to get the movie cost for each ID. And what we want is we want a dictionary. So for this ID, this is the cost, and we want to return that. Okay, so let's create a task group. Okay, so this task group is returning the cost, and this is the cost that we're returning, and this is the signature of that with task group. So here we want to put the child task result type, which we'll show in the next slide. This is what we want for the group result type. So basically, what you're waiting for here, and this is what the task group returns. Oh, so sorry. This is what the closure. This is the body of the task group. So this is very simple because we want to return in our method, we want to return int double dictionary over here, and this is what we're actually awaiting for on this cost variable here. So this is the simplest thing that you need to do. Just put whatever value you need, you put it over here, int double dictionary, okay, and dot self just to signify that this the type we want. Okay, and we have the get ticket cost method over here, and it returns a double. So our child task, and we're going to call get ticket cost in our child task. Uh, so the type will be double. Okay, and let's start writing the body. So we have a group, and now we need to do two things. We need to start the child tasks, and then we need to collect those results. Okay. Uh, so for each ID in the movie IDs, let's add a task, group.add task. That's how you add the task. And let's get the cost, awaiting on get ticket cost, and then let's return that cost. Okay. And now we need to collect those results, because remember, we are, when you add the task, it starts running, but you actually need to get those results and collect them so that you can return them at once. So let's collect those results. So let's have this child result dictionary, and for each ID, just like how we added the tasks, we can do for each ID in movie IDs, and then we can put those values in that ID. And since group is conforming to async sequence, you can do group.next. So it will just give you the next available result. Okay, there is an issue here. And now, if you recall, at this point over here, I did say, yeah. Child task may finish execution in any order. Now, this is the important point. So here I assume that the results would come in the same order that I actually started the task in, which is obviously a bad assumption to make. So let's redo this piece of code. So instead of returning double by itself, so here we were returning double. Instead of returning that, let's return the ID as well as the cost. Right. So for that, we change the type of the child task result here. And now let's collect the results properly. So we can now await the tuple, because ID comma cost is the return type for the child task. So we can just await that tuple in the group, and then we can add it. And once that's done, then we can return the child results, which will get assigned to cost, and we can return cost. So this is how you can create a task group and how you can use the task group. You don't actually have to return anything in the child task. If you don't, if whatever you're adding doesn't return anything, you can just do void.self here, which basically means you don't return anything. Let's see. Yeah, sometimes Swift is smart enough that you don't even need to specify in double, and if you just put it in the closure body, like what the group will return, then that's also good enough. You don't actually need to specify this over here. And even better, like sometimes it's so smart that you can just return directly. You don't need to specify anything except for the child task result. And I don't even need to specify that the result type of the group is something. So I just return await group.reduce. So this is a different method for getting the total cost. So yeah, we can just do stuff like this, await group.reduce 0, comma plus, to get the total cost of the tickets if you wanted to do it like this. Okay, and I showed you with task group. There's also with throwing task group. So if you have like methods that throw, like this get ticket cost throwing, and what you can do is you can do a try await here, and you can return this value like that. And the collection is the same. You just put a try over there. So it's like basically the same thing. Just put a try where needed. Okay. Yeah, if you just want to see, this is the signature that's from the Apple documentation. This is what the signature looks like. I guess I went too deep into this, but it was a bit confusing to me exactly when I was learning exactly what type was needed where. So I hope I didn't bore you with that. Yeah, and uh, some time ago I had mentioned that I would show you an example of what goes wrong when you actually try to mutate something in a sendable closure. So group.add task is a sendable closure, and this example here where I have the costs declared outside, and I just try to edit the cost right here, just put the cost ID in the child task. You can't do that because it's a sendable closure. So you can't really mutate costs at this point over here. Uh, yeah, okay, let's talk about unstructured tasks. So task groups are over. Uh, Unstructured tasks, the good thing about unstructured tasks is they can be launched from any context, which includes the synchronous context. So all this time you may be wondering, okay, this is cool. You can use async functions from async functions. Okay, but how do you get the first async function? So you can just, uh, if you're in a synchronous context, you can just launch a new task and you can call the async function and everything inside there. So the lifetime of the unstructured task, it's not limited to any scope. So all the examples that we had seen, the async let and the task group, they're all limited to some scope or the other. But an unstructured task is not confined. You can create the task, you can store its handle somewhere, and at some later point of time, you can get the value or you can cancel it, whatever you need. And unstructured tasks inherit the actor isolation and priority of a written context. So if you're running on a background priority thread, if you create an unstructured task, the priority will also be background. And yeah, you need to manually cancel or await. So this is an example that's both shows like basically what async let does. Like it does something like this, but more with more Swift compiler features. So this is what we did, right? We did async let cost, and we can await that cost whenever we want. So you can also do something similar with tasks. And like I said, async let is just sugar for task. So you can just specify the return type of the task, and never just means you're never going to throw an error. And then you can await the value, and that's it. And you can return await cost task dot value. So similar things, just this is just cleaner to write overall. And same here, if you are actually going to throw something, then you can just put the type of error over here, and you can try await. Okay. Detached tasks. So they're basically unstructured tasks, but they don't inherit anything at all. They don't inherit the priority. They don't inherit any task local values. They don't inherit the actor context, nothing at all. So it's great for starting up work and just putting it in the background. So I'll give you an example of that. One second. All right. So we have a gallery view controller, and when we are going to display a collection view, when we're going to display a cell for this collection view, we want to download an image or the thumbnail for it, and then we want to display it. But since this is a delegate method and this is not async, we can't just go to the UI kit team and say, make it async for me. Uh, what we can do instead is we can kick off a task. So let's start storing these tasks somewhere. So just let's create a variable, and let's store this task. Let's create a new task in the for the index path. We'll store it there. And you know what? When the cell goes out of view or did end displaying, we'll also cancel the task. Because we don't want to download things like if the user just scrolling past the screen rapidly, we don't want to kick off like 30-40 tasks and then download all of them in the background when the user is not even looking at them. So we'll just cancel it if it goes out of view. Great. So okay, now we have this task. Let's get the thumbnail. Let thumbnail equals await. Get the thumbnail for the index path. This will be making some sort of network request, and we can update the cell with the thumbnail. And after that, we can also clear out the task so we don't accidentally use it anywhere later. Uh, you'll notice that we are actually not having to go to a dispatch queue .main.async, because by default all the code that runs like by default UI view controller, they run on the main actor, which is basically the main thread. So any task that you create, and this is not a detached task, right? So any task that you create like this will also inherit that actor context. So this is basically scheduled to run on the main thread when it's available to run. So you don't have to dispatch queue.main.async anything here. Okay, and let's also do something. Let's create a detached task, and we can give it a priority. Actually, all the tasks that I created thus far, you can create a priority to this as well, and even the task group you can create priorities like that. And inside this detached task, we can use structured concurrency inside that. So inside this detached task, we can like suppose we want to cache the thumbnail and we want to do some tracking, like logging what the user's looking at, all this stuff. We can add this task over here and see void.self is the return type because these two methods don't return anything. And we can just have this, and all of these guys will automatically run in background because like this is structured concurrency, right? So it inherits the priority. So this is all running in the background, and if you later wanted to cancel all of these, you can just have a handle to this detached task and you can cancel it. All of these will get canceled. Great. Yeah, so you can see these are the various priorities that are currently available. And obviously, like the executive will prefer to run the high priority task first. There's also something that I noticed, which is not really mentioned that much in the WWDC talks, but the priority of the low priority task can be elevated to a high priority task if it's basically blocking another high priority task. So uh, it just ensures that everything runs smoothly. And they have a word for it called priority inversion, which is the issue that happens. But yeah, that's the basic gist of it. Yeah, and here the some of the like the initializers for the task and the detached task. So you can see that you can optionally give it a priority over here. And even in the task group, we can optionally give it a priority in the task group itself. So we haven't used that because we didn't need to, but you can put a priority over here. Okay, let's talk about actors. So uh, actors are these kind of new types that are introduced in Swift 5.5, and they basically help us synchronize everything. They help us ensure that data races and all these are not occurring. So let's yeah. So first of all, actors isolate their own state from the rest of the program. Uh, so if you have something that two different tasks want to work on at the same time, and they start changing writing stuff at the same time into it, you can imagine all sorts of problems that could happen. So for example, if we have a counter and we are updating the counter value from two different places, so and then reading that value, so one of them reads if the initial value of the counter is 0 and one of them reads 1 and the other reads 2, that's okay. If one of them reads 2 and the other reads 1, that's also okay. It's just whichever one executed first. But if both of them read 1 and both of them read 2, now we are in an inconsistent state. And that can happen when, suppose the first guy to get in there was waiting on something, and the second guy that gets in, he reads the value, updates the value, writes the value, and after this the first guy writes his own values, overwriting what the second guy had written. So that's how you can get an inconsistent state. So having 2 comma 2 like both the tasks reading 2 as the counter value isn't correct, and that will break your program. So actors ensure that this doesn't happen. So they isolate their own state from the rest of the program. And yeah, they provide synchronization, avoid data races. And this is the most important thing. Only one task can access the actor state at a single time. So this is how we ensure that there's no data race or anything happening like that. And just like classes, they are reference types, but unlike classes, they cannot inherit. They do support protocols, but they do not inherit. Okay. Uh, Methods from, so if you are already inside the actors, then uh, then you don't really need to await. So I'll show you this example in the next example. But basically, it means that when you're writing the actor from inside the actor, you don't have to do any sort of awaiting. So let's look at this example. Uh, let's give you a minute to soak it in. So we have an actor, which is called a cache downloader. So we're just creating an image downloader that caches whatever it downloads, and this is the stuff that's declared in it. So we just have a constant cache path. We have a variable for caching, and we're also, when we download something, we also add some metrics that okay, this URL was downloaded these many times. Okay, uh, we look at this download method later. But let's first look at this get most downloaded method. All it does is it looks at the metrics and it finds the one which has the highest download count. That's all it does. So it returns the tuple. So nothing looks different. This is just like a class or a struct. There's absolutely no difference here. The difference will come when we use this. So let's look at it from outside. So we create a cache downloader, put the cache path with the path is just this. That's fine. That's normal. No difference here. We print the cache path. That's also normal. But if you notice here, this cache path is an immutable variable. It's a let constant. So constant you can access no issues. But let's try doing something else. Let's try accessing the most downloaded method over here. Here we need to await. Even though this method is not really marked as async, we need to await because whatever task is accessing this needs to wait for any task that was accessing cache downloader to leave. Okay, so if any other task is accessing this cache downloader, then it's basically suspending the current task that we are on, because only one task is allowed to access it at a time. So that's why you need to await when you access anything like this. So this is just a let constant, so you can just access it directly. But you need to await when you're accessing methods, or if you're accessing mutable variables. So remember, metrics was a variable. We could change it. So the exact same definition of get most download, I just copied it outside, and we still need to await. So it's not just methods. You also need to await on mutable variables. And similarly, to get the image, we need to await. Like, even okay, this one is asynchronous, so that makes sense that you need to await. But we are awaiting for two reasons here: one for the download to actually happen, and one for the if there's a task, so that task needs to quit. So okay, let's show you the download method now. uh, it's very simple. We just, if we already have the image, we return the image. Otherwise, we get the image and we store it in the cache. We update the metrics, we return the image. No issues. uh, there, however, is an issue here. The issue is that uh, at this point we awaited for the movie image to come. So at this point, the task that's accessing this download method is suspended. What that means is there's no task accessing this actor at this time. So another task can come in, right? Because this task is suspended, and another task can come in and it can say, I want to download a URL, and the actor will say, yeah, sure, there's no one working on me right now, so you can access, you can download. uh, so here's the issue. So let's say I was downloading from some URL, and the other task that comes in, I come in here, I suspend. The other task that comes in is also downloading from that same URL. Okay. uh, Now that task finishes first. It gets an image and it stores that image in the URL, and and it updates the metrics, and that's great, and it leaves. And at this point, our tasks, the one that we had initially started, that finishes. But the issue is, we assumed that cache URL was empty before we awaited. We assumed that cache URL was empty. There was no image in that. So here, at this point, we're going to actually overwrite whatever image the second task had set for the same URL. Like, imagine that in between the two tasks, the server changed what the image was hosted. So basically, that's wrong, right? Because we have uh, we have overwritten our cache, which is not what we wanted to do. We wanted to cache the image and only get the image from the cache. But because we assumed something uh, before the await, and we carried that assumption over after the await, we are now we now have that problem, and this is called actor reentrancy. So the way you fix that is just you verify that the assumptions that you had made before are still valid. So we had verified that there was no image in cache URL. So we just say, okay, don't do anything. Basically, don't do anything if cache URL already has an image. Otherwise, set it to image and put that there. Okay, yeah, that's called actor reentrancy. So the guidelines for making sure you don't get stuck in this sort of issue that I showed here is whatever mutations you're performing, just put them in one synchronous block of code. So, uh, so the reason for that is, like I told you, you can never suspend in synchronous code. So this code is never going to suspend in between. So whatever sort of updates you're doing to the cache, that will not be affected by awaits or anything, because there's no await between, so no other task can come in, and you can't destroy the state's correctness. And the second thing that you need to do is you need to check your assumptions about the actor and the overall program state after an await. So just like here, we assume that cache URL was nil. So after the await, it will still be nil. That's the assumption that we made, and that's what we need to check. So if there's any other assumption, because not just the actor state, the overall program state will be changed. Basically, you can almost guarantee that the overall actor state will change. The overall program state will change somewhere. So if you made any sort of assumptions, you should check those assumptions. Yeah. So you can also mark some methods as non-isolated, and these non-isolated methods are only allowed to access the immutable properties. Uh, so external corners, like any other task that wants to actually use that method from the actor, doesn't need to await when accessing that method, because you're just accessing immutable properties. Like for example, we had access this cache over here, right? We can access it with no issue because it's an immutable property. So when we say a method is non-isolated, we say that this method will only access immutable properties, so you don't need to await on it. And by default, in an actor, all the methods are marked as isolated. And you can also mark computed properties as non-isolated. So let's just take an extension of that cache downloader, and I want to make it hashable for the purposes of this example. I want to make it hashable. So the static function, so recall that this is only accessing, I'm only accessing immutable values here. So I can just do this because I don't need to await because these are immutable. And over here in this method, I mark this method as non-isolated. And then after doing that, I only access the immutable variables or the immutable constants. And that's why this hash method doesn't need to be awaited on. So that's how you make non-isolated methods. And similarly, you can create a non-isolated variable cache URL. And since it's only accessing the cache path, you don't need to await when accessing this from outside. Okay. Uh, there's there are, like I showed you some actors. There's also some global actors, and currently I think there's only one global actor in Swift, which is called the main actor. But you use a global actor when the data that you need to isolate, or the data, the operations methods, whatever, all of these things that you need to isolate, they can't be put together in a single class. Okay. uh, so think about all the global variables that you'll have in your class, in your entire program. Like it may be possible to put all of it in a single class, but usually that's not the case. And think about all the UI stuff, related stuff that we have across Swift UI, or all of the foundation places. We have so many UI related stuff. All of that needs to be working on the main thread, right? So all of that, so basically we can say all of that needs to be working on a single actor. So so that's why we have global actors, which you can just mark something as being part of that global actor. So it will ensure that uh, you can perform isolation across like really scattered stuff. So how you do that? Whatever thing you're declaring, you just mark it with the attribute for that global actor, and I'll give you an example in a bit. And that's it. That's all you need to do. And it's not like you can no longer access these global actor methods from elsewhere. You can still access them, but you'll need to await to actually access them. And yeah, if you are accessing it from the same actor context, the like just like before, we could access the mutable variables from within the actor. We didn't need to do anything. We didn't need to await. So just like that, if you're in the same actor context, then you can just access it synchronously. You don't have to do any awaits. And global actors, if they're declared on something, then you can actually infer that by subclassing. So for example, UI view controller is already marked with the main actor attribute. So any view controller that you make that conforms to that, you will already be conforming to main actor. You'll already be isolated to main actor. So just keep that in mind. It's not like super clear, when you're actually just writing code without looking. But if you just look at the definition for UI view control, you'll see that it's marked as at main actor. Okay, so let's look at a couple of examples. So I marked this function and I marked it with at main actor. So this function only runs on main actor, or not only runs, it runs on main actor, and it can still be accessed from outside. This other function, we also mark it as main actor, and we can just call it directly, no await required. But inside this function, I detach a new task. And this, remember, detached tasks don't inherit the actor context. So this is basically running without any actor context. So now I can say when I want to access the function that runs on main actor, I'll have to await on it. Or if I want to access any sort of property, I'll have to await on it. Yeah, so let's take a closer look at main actor. So this is basically the actor that represents the main thread, and it's synchronized on the main dispatch queue, and it's even interchangeable with the dispatch queue.main. Uh, like I said, it's a global actor. So, and I already mentioned that the UI view control and other UI classes also are already annotated with at main actor. Okay. So yeah, this is implicit. It's already there, but I'm just showing you for this example. And this function on button press, so it's implicitly isolated to main actor. But if you did want your some method to not be isolated to that main actor, then you can, like similar to what we did in the actor itself, we can just mark it as non-isolated, so it will not be isolated to that main actor. So any other task that's running on some other actor, then it can also access this without having to await, basically. So it can still access this on button press, but it will need to await. Yeah, this is another alternative to dispatch queue.main.async that we have in 5.5. So instead of calling that, you can use a task.detached and you can mark it as main actor. You can mark the closure as running on main actor, and then you can use it just like that. Okay, this is an example for a global actor. So basically, in this example, we have a remote config actor. So the actor type is defined as remote config, and we can declare a shared remote config actor. And when you mark it as when you mark something as a global actor, all it cares about is you have a shared actor that's present, static shared actor that's present. So afterwards, you can mark declarations like this this list of strings. You can mark it as isolated to RC actor. You can mark this method as isolated to RC actor, and you can see in this example you can access global configurations without having to await on it. So we are getting some data, and then we're passing that data all synchronously. This is not synchronous, this is synchronous, and we are setting global configuration. We don't need to await when we do the set. uh, However, when we're running on a different actor, so this method I've marked with main actor, when we're running on a different actor, I will need to await to actually read global configurations, because we're not on the same actor, and these configurations I need to await. So if global configurations contains new experience, we'll show the new experience on the home screen. Okay. Final topic: switching to async in code that you've already that's already there, like in your production code, whatever. Uh, So basically, there's two easy methods, something that Swift already provides, continuations, like check continuations and check throwing continuations. So let's take a look at this function here. So I think we started with this function, so let's go back to it. Uh, this function is taking a handler, and like we've already seen that, right? So how do we convert this to an async function? So we don't have access to this code. Like we could copy paste everything, but suppose this is coming from an API and we don't even have access to the code. So what you need to do is you just declare the new function, and you can have the same name, but since the signature is different, so it's counted as a different function. And we are returning the value that this check throwing continuation will return. And we have this closure, and it will give us a continuation that we can use. And let's call the download thumbnail method, and in the callback we'll have the result. So if the result is a success, different from the first example, we are actually returning it in a result type. So if the result is a success, then we can continue. Then we can resume the continuation with the value, the thumbnail. If it's a failure type, then we can resume it by throwing the error. So that's why it will with check throwing condition. So that's why it's throwing the error over here. That's why we need to try it, and that's basically it. Uh, However, this paradigm is so common. There's another way of doing the same thing, and we can just directly resume with the result, and it will just unpack that for you. You don't need to do the switch. You don't need to do this entire switch. You can just do this directly, and yeah, it will just take care of that. If you have delegates, and this doesn't look as clean as what we just saw, but if you're for example, let's take a look at this image downloader delegate, and once this image downloader downloads, it will call on its delegate the did download method, or it can call on the did throw method depending on what happened. So let's create a view controller, and we have the image downloader. We set that up. We have the delegate, and we have the delegate methods. Currently, we don't have anything in that, but we'll do that. We'll put that there. Okay, so let's hide that view did download method, and we'll create this download thumbnail async method that we'll use to call this downloader, image downloader, that we'll call. Okay, so again, try it with check throwing continuation, and the return type is going to be a UI image. We know that. So let's store this continuation somewhere. So when the like for now, let's just take this continuation. We can store it wherever we want. So let's store this continuation in the view controller state, and let's start the download. Okay, great. Over here, what we can do inside the delegate methods, we can resume the stored continuation with the returning image, and then we can set the stored continuation to nil. And similarly, we can resume with the throwing error, and we can set the stored continuation to nil. This part is actually really important, because if you resume a continuation twice with whatever value, if you resume a continuation twice, that's undefined behavior, and you likely get a crash. So I did it for you, and if you try to resume it again, you will get a fatal error. You cannot do that. So be sure that when you store a continuation, you're only resuming it once. And even when you're not storing continuation, even if you're doing something over here, you're only resuming it once in each branch. So basically, you're not allowed to call the resume twice at runtime. You're allowed to call it twice in different if conditions and all that. And that's it. That's the entire Swift 5.5. I've covered basically everything. In conclusion, I am really liking the new features available in Swift 5.5. It makes the code much cleaner to read, and it makes it easier to write. But if you're supporting things, if you're supporting iOS 13 or some stuff like that, then it won't be usable, because it's limited to iOS 15 for now. But I'm still excited. And yeah, any questions from you guys? This was a long session, but yeah, I'm available for questions now.
I think, Mudit, your examples were pretty clear and well articulated that nobody asked any question. Guys, if you have any questions, just post it in the comments.
Oh yeah, references. If you want to check this out, we'll share this PPT with you. But these were the best places that I found the most help while preparing for this. And you can check them out also. There were some other places, but I don't remember those.
All right, I think we can end our session for today. Thank you, Mudit. It was a very insightful event. Yeah, thanks.
Yeah, thank you
Thank
for
you,
having me.
everyone, for joining. See you next month.